studying parabolas, I was always taught to find the vertex of the parabola by using kind of a little trick where I knew it was negative b over 2a if I could get that equation into its general form, ax squared plus bx plus c. If I could get it in that form, I could find the vertex by first taking those coefficients and taking the opposite of b and dividing it by 2a. And then I could plug it back into my function to figure out what my y-coordinate was. But I always wondered why. Why this negative b over 2a? Well, there are a couple ways you can figure it out. One way is by using the quadratic formula. By using the quadratic formula, we can talk about the roots and figure out where that negative b over 2a comes from. Another way we can do that is to look at completing the square and put it in vertex form with just the general equation. And the last way, we can actually use calculus to look at where the slope is equal to 0. In other words, the maximum or minimum. So let's first look at using the quadratic formula. When we do that, we'll be looking at the function f of x is equal to ax squared plus bx plus c. And we're going to look at that to find the roots of that general equation, where f of x is equal to 0, or where this function is crossing the x-axis. Now we can find the roots of the general equation by using the quadratic formula, which is derived from completing the square. So we know that x is equal to negative b plus and minus the square root of b squared minus 4ac all over 2a. That gives us two general solutions, negative b plus the square root of b squared minus 4ac all over 2a, and negative b minus the square root of b squared minus 4ac all over 2a. Those are our two general roots. If we're looking at a parabola, those general roots are where this parabola crosses the x-axis. Now notice, in between those two roots, exactly in the center, is our vertex. This happens every time. Parabolas are symmetrical, and so the roots, when folded in half over the vertex, have to be on top of each other. So here we have one root here and another root there. The vertex is exactly in the middle. So if we can find the middle of these two roots, we can find that x-coordinate of the vertex. So in order to find that, we're going to take these general roots, we're going to add them together and divide by 2 to get the exact midpoint. So the vertex, remember, is halfway between those two roots. So then adding the two roots together, we have negative b plus the square root of b squared minus 4ac all over 2a, plus, we're adding the roots together, negative b minus the square root of b squared minus 4ac all over 2a. And since we're trying to find the average or the midpoint, we're going to divide that all by 2. So now we've got these general roots we're adding together. So we have negative b plus negative b. That gives me a negative 2b. And then we have positive square root of b squared minus 4ac and negative square root of b squared minus 4ac, and they just make a 0. So that's all over 2a. And then let's not forget that that's all over 2. We can simplify this a little bit. We know negative 2 over 2 is just the same as negative 1. And then we have the b and the a, so that's really the same as negative b over a all over 2. Now if you need to, you can rewrite this in a nice form so that you can really figure out what you're doing there. You can rewrite it as negative b over a times, now this is the same as 2 over 1. So when I'm dividing, that negative b over 2a divided by 2 is the same as negative b over a times 1/2, which gives me negative b over 2a. And that gives me the x-coordinate that's in the middle between those general roots. Now, to find the y-coordinate, all I have to do is plug my negative b over 2a, substitute it back in to my function to find the y-coordinate. So that's the first way. We can do this another way as well. We can use completing the square. Now we can use completing the square to put the parabola in vertex form, in the general vertex form. Now we know the vertex form of a parabola looks like f of x is equal to a, some coefficient a, x minus h, and that's the x-coordinate, squared, plus k, and that's the y-coordinate. So h is your x-coordinate, k is your y-coordinate, but if we look at the general form for the parabola, f of x is equal to ax squared plus bx plus c, we can use that and put it into vertex form to see if we can find the vertex in terms of a, b, and c. So to do that, first we need to separate the coefficient from the x squared term. So we have f of x is equal to a, and we have parentheses around there. That's x squared. Now remember, it's b over a, because if we distribute b over ax, if we distribute that a, we get back to just b. And then we keep the c on the outside. Now in order to complete the square, we're going to go ahead and half b over a, and then square it. Now we're going to add that to our center here because we want that perfect square so we can get it in vertex form. So b over 2a squared. Now really when we're adding this, we're not just adding a b over 2a squared. Really we're adding that b over 2a squared times a, and so we have to subtract b over 2a squared times a. So we've got to add a negative of those in order not to change the value of the equation. So here's our a right here. We must multiply it by a because really that's what we're adding in that center there. So we get a negative b squared over 4, and we don't have an a squared, we just have an a because that a over a makes a 1. So 4a. And we're going to add a negative b squared over 4a to counteract what we added in the parentheses. Now we can go ahead and put that in factored form, which gives us a perfect square. So we have f of x is equal to a, and then factoring that, that's just x plus b over 2a squared plus c minus b squared over 4a. Now we have it in vertex form with all of our original coefficients from the general equation for a parabola. So now the vertex we can find, that's just my h comma k, is going to be a negative b over 2a because it is x minus h, so we have to add a negative there, comma c minus b squared over 4a. Now this is the same as if we were to take that negative b over 2a and put it back into my function for x. We would get out c minus b squared over 4a. Now the last way we're going to look at is using calculus, and we're going to use that instantaneous rate of change. So we want to look at a parabola and examine what's happening with the slope. So if we've got a parabola right here, we can look at the slope. The slope is changing. And if we look at that, see that as we get closer to the vertex of the parabola, our slope is getting less and less steep until we hit the very bottom of that parabola, in this case, at that vertex, and the slope is 0. So if we can find where the slope is 0 on a parabola, if we can find that x-coordinate, we will have the vertex. That's the only place on that parabola where the slope is equal to 0. Looking at the general form of the equation for a parabola, ax squared plus bx plus c, we can take the derivative, realizing that a, b, and c are coefficients. So f prime of x, or the derivative of f of x, is 2ax plus b. Now we're looking at where that derivative, that's the derivative for the whole function up there. So that tells us the slope at any x. And we really want to know, what is x equal to? What is x equal to when the derivative or the slope is equal to 0? So 0 is equal to 2ax plus b, where x is my variable. And I want to find out when that's true for x, remembering that a and b are coefficients and just numbers. So I'm going to go ahead and solve for x. Subtracting a b from both sides, I have negative b is equal to 2ax. Divide both sides by 2a, divide by 2a, and I have x is equal to negative b over 2a. And that's where the slope is equal to 0 and my x-coordinate of my vertex. So the vertex in this case is negative b over 2a, comma, and then I can plug that back into my function, substitute in negative b over 2a, and I can find my y value. So that's another way where we can look at why the x-coordinate of the vertex, the x-coordinate in this case, is negative b over 2a. So we looked at 3 different ways: the quadratic formula, the regular equation in vertex form, and using calculus. Now you can say why the x-coordinate of the vertex is negative b over 2a.